With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello. We are given with a question and the question says figure shows a cubical block of side 10 centimeter and relative density 1.5 suspended by a wire of cross-sectional area 10 to the power minus 6 meter square. So it has cross-sectional area 10 to the power minus 6 meter square. The breaking stress of the wire is this much. The block is placed in a beaker of base area this much, and initially that is at t equals to 0, the top surface of the water and the block coincides, as we can see in the figure itself. There is a pump at the bottom corner which ejects 2 centimeter cube of water per second. Find the time at which the wire will break. So here breaking stress is given already. So we can find breaking force. Breaking force would be equal to breaking stress into the cross-sectional area. So that can be written as, since breaking stress is 7 into 10 to the power 6 and the area, cross-sectional area is given as 10 to the power minus 6 here, right? So it would be 7 Newton. Now, since breaking force is 7 Newton, what happens when the block is in a liquid? So it experiences some upthrust force, right? So first of all, we'll find the weight of the block. So that would be equal to, we can write it W only. So that would be equal to volume into density into G. Volume into density is M into G. So that is equal to, volume is for the block is, it would be 10 to the power minus 3 meter cube. Why? Because 0.1 meter is the side length, side, like the dimension of a side, right? So into density. Density here, relative density is given, that is 1.5. So it is relative to water, so it would be 1.5 into 10 to the power 3 into G 10. So this and this cancels, it would be 15 Newton now, right? Now, what we can say is that the upthrust, when liquid level descends by x. So the upthrust, that x here, would be equal to upthrust, comma, we can represent it by F simply, right? And we can represent break. So now we can represent breaking force by FB, right? Now, since this is 15 Newton, we can write F. The upthrust force is represented by F here. Upthrust, so that is F. So when it descends, the water level descends by x. So it would be, the volume would be, the area is 100 into 10 minus x would be the one side, right? The height into 10 to the power minus 6 to be converted into meter cube, since 100 into 10 minus x is in centimeter cube, into the density of water, that is 10 to the power 3 into G. So it was, F was equal to rho submerged into the volume submerged density of water into G, right? So this would be equal to, so this would be 10 to the power 4 and this 2 is 10 to the power 6. So this cancels out and we get 10 minus x Newton to be the upthrust force here, right? Now, after that, what we can say is that the net downward force, there would be some tension later on, right here. So net downward force would be equal to, T would be equal to the total downward force. So that would be 15. Since on block, it would be 15 in downward direction. The 10 minus x in above direction and tension in the above direction, right? So that will be equal to 15 minus 10 minus x. So that turns out to be 5 plus x Newton, right? Now, what we can say from here is that when tension equals the breaking force, the wire will break, right? So therefore, what we can write is 5 plus x should be equal to 7. So if x is equal to 2 centimeters, right, at that time we would have the breaking of wire. So now what we are given is here that ejects 2 centimeter cube of water per second, right? So we can write, so now we can say that the volume displaced here would be equal to 200 minus this 100, the area of this block, into 2, right? So it would be 200 minus 100 into 2. So that would be equal to 2 centimeter cube into T, right? So T can be written as 100 seconds from here, right? So our answer would be this, that at 100 second, the wire would break. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.